Good morning, everyone. Welcome to the FireScope webinar series. Today, we're going to be talking about 3 ways to speed up your Cherwell implementation. Today, presenting will be Devin Bradshaw. He's our Director of Field Engineering for FireScope in our central region. And we also have Paul Yates. He's our Senior Technical Consultant with FireScope Europe. Both of these gentlemen have a lot of experience doing implementations of our FireScope solution and experience working with our customers in Cherwell environments. So they are definitely the people we want to have on this webinar. Before we delve into FireScope, let's just talk a little bit about some industry trends. Now, according to Gartner, 90% of CMDB implementations fail. And what really shocked me the most is most organizations actually fail 3 times before they successfully implement a CMDB in their environment. So this probably explains why CMDB is considered a dirty 4-letter word in most people's vocabulary. Why is this? Well, according to Gartner, poor inventory and discovery tools. A lot of people try to use an asset management solution as their change management, and it fails. This leads into the second point, which is poor reconciliation and normalization capabilities. In plain English, we're trying to match Excel spreadsheets that some people might have, other people might have Word documents, other people may have started a CMDB solution. So it's a matter of trying to figure out whose data is most trustworthy, when was it updated last, etc. Also, too, manually populating the CMDB. A lot of organizations on the forum chats that I've seen, I'm still surprised by the number of people that are trying to manually enter in hundreds, if not thousands of CIs. And then, of course, when changes are made in the production, how is that reported to the CMDB? There's a term that's been floating around that's called shadow IT, where people are bringing in IT devices from the outside into the environment. So if they are, how do you track those specific changes, or how are you even notified of those changes? In other words, your CMDB is almost out of date as soon as you populate it. So the keys to a successful CMDB deployment and what can help dramatically speed it up, of course, is making sure that you tie your CMDB goals to improving a business service. Essentially what this means is don't boil the entire ocean, just take it one spoonful at a time, which leads us to the next point, having a great discovery and dependency mapping tool. Gartner recommends that having a full scan of all the assets that support your business services, and of course, identifying all the dependencies of those assets. So a good example of this might be if you have a server in your environment that is supposed to support one critical business service, but then you discover that it's actually supporting 4. That now becomes a single point of failure. And by having a discovery and dependency mapping solution in your environment, you can actually see that represented on the screen. When you do run a scan of your environment, understand all the dependencies that support your business service. Of course, it's always a benefit just to be able to have that one-click upload into a CMDB. And then finally, to make sure that your CMDB does stay current and up to date, having persistent scanning that will help detect and identify any changes that are inside of your environment automatically. And with that, I am going to turn the presentation over to Paul.
Thank you, Cliff. So I'm going to quickly go through how SDDM can help with this automatic detection of CIs and their relationships and populate the CMDB, and tell you how we install the solution and how it actually does the magical business. So the first thing we need to do is to install an edge device. This is simply a virtual machine which we supply as an OVA. Normally you'll have one of these, but we might have to consider multiple if your infrastructure demands it, and there's no extra cost. You can have as many of these as you like, but it's all about the simplest way to collect data and get it into our software. Then we'll start looking at traffic flows, and that's how we'll build your models of services and how the CIs relate to each other. So we passively consume network traffic. We're only looking at the headers. We don't read any packet data, it's just the headers. No other software is required. We don't need admin domain access. We don't need software to be installed on servers to get the data. We're literally just looking at traffic flows. So where you've got physical devices will need things like NetFlow, SFlow, port mirroring, network taps, promiscuous traffic, any way combination of those to get us all the data from your physical switches and routers so that we can see the entire physical part of your network. And then we need to couple that with traffic flows from your virtual devices. And this basically boils down to two scenarios. You'll either have virtual switches, in which case we'll need a collector on each ESX host because it's the only way you can see traffic between the local machines on a switch. Or if you're fortunate enough to have distributed virtual switches, we can just enable net flow across the distributed switch and send the data to the edge and consume everything in your virtual environment with one tick box and one IP setting. Once we've collected that data, we sample, we analyze it, and we aggregate it together, and we present a list of the traffic we've seen. So we're literally looking at what's the source machine, what's the target machine, what port are they talking, and how much traffic gets sent. And this is like a sort of phone bill type affair that we've produced that shows you the traffic that we can see. The only other piece of the puzzle that we'll need at this point is cluster information. We need to fulfill the link between a virtual IP and the members of that cluster, because without that, we'll see data going into one side of the equation and nothing coming out the other. We won't know how that links together. So we have automatic ability to query clusters, get the virtual IPs and the members, and we'll build that into a list of cluster information here. Once we've got that, we're able to detect likely service entry points. So this is where we've detected clients connected to machines but servers. So we're saying this must be the start of something. So we'll present you a list and you can say, yes, that's my service, that's the one I want to map, tick the box, create a new service group, and we'll go and map it. And when I say map it, we will literally produce a map. So this is a typical service map showing how servers talk to each, what ports they talk on. These are clusters. So this is a cluster we've pulled out of the load balancer that shows we've got a virtual IP and some members, and they're talking to these relative servers. As you can see, we've got some dotted lines and some solid lines here. The dotted lines indicate that since we last scanned this map, something's changed. So we need to go and find out, because we're checking it in real time, what it is that's actually changed at this point. So common question is, well, which service would we build first? Well, contrary to what a lot of people might think, experience has shown value in starting with the service you understand the most. The reasons behind this is it promotes useful discussions on which elements of a service you actually want. Do you want to see the clients? Do you want to see DNS? Do you want to see antivirus backups? And that question will change from person to person. I've had it where I've had two people in the same room, one saying he wants to see the clients because he's a security guy and he wants to see everything connected, and another guy saying, I'm not interested in clients, I just want to see my service. So we build the services to your requirements. We just need to understand what those are. So we need to have that discussion. It also helps build exclusion lists. Why do we need exclusion lists? Well, there's going to be parts of the service that aren't, as I've said, actually part of the service. We'll detect things like backups and antivirus and DNS. So we'll exclude those by IP ranges or IP ports, port ranges. It's important to define those so that we can focus on the service components you really want and get to the proper service itself. But then also it builds confidence that we're seeing traffic across the entire network. If there's one switch that isn't sending us data, we're going to have a gap, and we need to bridge that gap. We can't have gaps because we can't follow the flow of data without it. So it just builds that extra bit of confidence. How do you know when you've built your service, when it's complete? Well, the answer is quite simply, you have to get buy-in from the service stakeholders. This is an interactive process, as I described a minute ago, where we're asking them which parts of the service do you want to exclude, what parts do you specifically need. So we need the service stakeholders to understand that when we present what we believe is the complete service, they can approve that and say, yes, it actually is. So agreement needs to be reached between them that the model actively reflects the service. This further supports the recommendations, as I said before, about starting with your best known service. When do you then send that service across to the CMDB? Well, what do you do in the implementation phase? We'd recommend you do it one service at a time. because as you'll see later, you need to perform some CI and field mapping. So we need to make sure that we've got those right. So build a service, get it to an approved baseline, and then migrate it across to the CMDB to ensure the CMDB integration is working correctly. However, once you've completed the implementation, the only time you'll ever need to redo this is when the service changed and has been reapproved. So with that now, I'll pass over to Devin, who's going to talk about asset discovery.
All right, thank you, Paul. Yeah, so the first thing we're going to talk about here is kind of the scope of that discovery. One of the questions that comes up normally is, should you scan the entire network for devices? Our recommendation is normally, yes, you would like to. You'd want to, is just like what Cliff stated earlier with the shadow IT, you want to make sure that you have your entire organization discovered so that you can know what CI types you have, and also find out those actual dependencies. Now, one of the reasons that you would want to scan your entire network, other than understanding the totality of your devices in your environment, you also want to understand those relationships between those devices. Which CIs are VM hosts, which ones are guests, what's their relationships between those different disparate devices. And lastly, one of the reasons why you may want to do a partial scan, or what you may actually be averse to a partial scan of your environment, is that, again, it only shows a small piece of those dependencies in your infrastructure. So if from an ITSM perspective, or from asset discovery, you want to discover your entire environment, relegating it to one DC or one data center probably isn't the best approach. So we always suggest that you try to scan your entire environment, unless just from a scope perspective, that's not necessary for your project. Now, one of the things too is, so why do you need to understand those dependencies? Why is it so important? This map here is a map that if you've gone to other webinars you've seen, and you may see again, but this just shows you how all those different disparate devices could be interdependent based upon the different service maps. So if you remember earlier in a couple slides before, Paul showed the similar map, yet we had attached some additional network devices and their interdependencies to that map that he showed earlier. And again, those dependencies could be used in other areas as well. And lastly is, how do you establish a baseline? That's one of the most important areas. Once you have the service, your service map created, what you're going to want to do is you're going to want to converse with those other application owners or those service stakeholders, like Paul stated. You're going to want to have that conversation with them, sit down with the map, see if the map, the different devices or the different CIs in the map are correct, and that if those actual dependencies and relationships are correct as well. Once you've agreed upon the elements of that service map, then within SDDM, you can approve those dependencies. Once those dependencies are approved, just like Paul stated earlier, it'll go from a dotted line to a solid line, which means that is your baseline, and those are your dependencies that are approved. And those dependencies will be federated over into your CMDB along with the CIs and the actual configuration item profile details about that CI. And with this, I'm going to hand it back over to you, Paul, so we can talk a little bit more about FireScope and Cherwell.
Thank you, Devin. So I'm going to talk to you now about how we prepare Cherwell for FireScope data, what we need to configure and get the data actually synced across. So the first thing we need to do is prepare the Cherwell server itself. We have a small integration map which needs to be installed on the server. This is a standard part of Cherwell software integration, and ours just bolts straight in. And all we need then is a FireScope user and a client key to be generated. So we need the URL of the server, the client username, password, and the client key. And from there, we're ready to go and start talking to the Cherwell server through its API. Our integration's been developed in hand with Cherwell, and both parties have bidirectional support through APIs. There's a button at the bottom here, a tick box at the bottom, which when you click it and hit save, instigates the first communication between us and Cherwell. And this is where we go and fetch the CI types from Cherwell itself. So what we need to do once we've got these types is map our types to the Cherwell types. You can define any CI types you like within Cherwell. So obviously we'll pull data like servers, network equipment, things like that. We need to know what you want to map those across to. So we can define rules for all these. So here you can see a rule that says, if the manufacturer of my piece of equipment happens to be Cisco, I can be pretty sure that's a network device, so I want it to go across the Cherwell config network device. Similarly, if it's running Windows, it's probably a server, and we want to send it across to the Cherwell config server CI type. Once you've done that, you only do it once per CI type. You then need to map the fields for each CI type. So Cherwell has their fields and we have ours. The names are different, the uses could be different. So we need to know, what do you want to map the fields across? So our name becomes Cherwell's friendly name, host name becomes host name, status might be asset status. You've got complete flexibility between all the fields in our software to the fields in Cherwell to mix and match them as you see fit. This column on the end though is important. This is where you decide who's the master data. So what we're saying here is we will, for the top two, we will only update the data if there's nothing in the field already within your Cherwell CMDB. So we won't overwrite any existing data. However, for the bottom ones, we've decided we do want to overwrite them. Now that's probably not appropriate for a proper business, but it's just an example that we can say, yes, we'll overwrite data. No, we will only fill data in that's not there. So we can add data to existing CIs, or we can create information over the top of what's already there. The next thing you need to do is create rules for the CI matching. And this is where we need to know how to match CIs already existing in the CMDB. We could just be doing it by IP address, but in some cases that's not appropriate because it's not available in existing CMDB data. So it might be a name, it might be a combination of name and IP address, whatever the rules are that you need to say our CI and the Cherwell CI match together for updating. Finally, we have rules to define about what happens when things have been deleted and when things need to be created. Do you want us to create them? Do you want us to create them if they've been deleted? Do you want us to do nothing if they've been deleted from the CMDB? It means you no longer need to know about them. What about relationships? Do you want those updated, deleted, and created? Once you've done all that, and you only need to do it once for each CI type, we're ready to start sending the results across. So we present you with a preview of what would happen if you did the federation. So what you're seeing here is this is our CI type, the CI name, but this is what it would go across to as the CI type within Cherwell, plus any CI to CI relationships that need to go across with it. What I typically do is I will have one Cherwell CI type that I never assign anything to, and I'll have that as a default rule that says if we don't assign a CI type to anything, use this default one, because it then means I can look for that default in here, and if I see it, there's a CI type I haven't mapped correctly. Once you're happy that you've seen everything, that you're confident that the export is good, you just hit the export button and it will be sent. So by design, the initial federation syncs are manual. This is to allow validation of the CI type mapping. It's absolutely important that you get these right because you don't want to put servers into network devices, for example. However, after a while, if you've got confidence that everything's configured correctly, we can automate that sync if required. So that's how we set up Cherwell to accept data from us and how we then get that data to and from Cherwell and SDDM. So with that, it's back to Devon for monitoring of changes.
All right, thank you, Paul. So you've created the baseline. What's next? What are you trying to do next? You've decided you've created this baseline. So what's the next step? Well, the next thing is just like Paul stated, you want to federate that baseline service map into Cherwell CMDB. And in addition, you can sync. What we'll do is we'll sync over the CIs and their relationships based upon which individual service map that you federate. And we'll make sure that we have both the CI, some information about the CI from a profile perspective, and also their interdependencies, both up and downstream into Cherwell. Now, once you've created a baseline, and let's say, just for example, you have a change on the weekend and you come back on a Monday morning, how do you identify if there's something has changed in your environment in terms of the service maps that you've created? Well, in our actual overview, which is our main overall dashboard, that will state how to, or for each individual service map, what's changed in the environment. For example, the green check are actually the blue check, or excuse me, the blue plus is new connections that they've seen. The caution or the yield sign is, or actually warning sign, excuse me, is the number of connections that have seemed to drop off that was maybe baseline before, but now we're no longer seeing connections. So if you can remember from a change perspective, when you come in on Monday morning after the change and you see that there is 41 connections, if we're looking at this Dallas authentication service map, that have since dropped off, but we've seen 72 new connections that have dropped in. And lastly, one of the most important things is, you've identified the change. What do you do next? If you already created the initial baseline, you federated over that initial baseline, you did a change on Friday, you come in Monday, there's a new change to that service map that you've baselined and already federated over. And maybe there are some new CIs that have been added to this application map. Or maybe some of the communication between some disparate nodes have changed and you need to approve that new baseline. So once you've seen the changes on the main screen, you'll go in, you'll make sure that you approve that new baseline. You'll go through that same iterative process that Paul stated earlier that you do initially for each change to any service map. And then you go through that same federation process. Now, one of the questions that most individuals ask is, well, how do you know if you should or shouldn't add or create new baselines for every change that you see for a particular service map? Our suggestion would be that any change that you see, you want to validate that change to a particular service map and either remove it or delete it if it is a new connection that shouldn't be, or validate and approve that new connection so that you can create that new dependency and then federate at that time. So I'm going to hand it back off to Paul, and he's going to talk about one of our success stories, and then Cliff will come with the summary. Go ahead, Paul.
Thanks, Devon. So yeah, here's a case study of a customer that genuinely we helped out using SDDM. So the situation here is they already had a partially filled CMDB, but as normal, the data was out of date. It had been imported from spreadsheets. Nobody had maintained it. Nobody was quite sure of the quality of the data. So we did a few trials with connecting to SDDM and having data going into the CMDB with their existing data. And then they realized, no, there was no benefit to that. So they wiped their entire CMDB and started again. They then used SDDM to detect all network equipment. So normally you would look for things like servers and routers and switches, but they went, nope, we want to see client PCs, we want to see printers, and we want to see IP phones. So we had to go and detect all of these and bring them all different CI types. They created CI types for the IP phone specifically in Cherwell, and then we started federating them across. For the printers, phones, and client PCs, we just sent them across as simple CIs. They weren't interested in relationships, but what they did want was the CI profile data, things like the name, the IP address, MAC address, and serial number where appropriate. So we were able to send all that detected directly off the network. For the servers and the network equipment, we actually mapped services. The resultant CIs and their dependencies were again synced to the CMDB as CIs with relationships, but we still included the CI profile data which had automatically been detected. So what we ended up with, they then took additional data from other sources and brought that directly into the CMDB. And this was from things like SACM and Active Directory. So they were able to add things like some software inventory information and some Active Directory with the membership information to the CIs from the data we'd presented. So what they ended up with was 1,200 CIs populated into their CMDB less than a week after we started the project. Once they realized that they had no use for the existing data, wiped it, we were able just to configure SDDM to take all the data we found on the network and populate the CMDB with it. So that was quite a project. And with that, back to Cliff to finish off.
So in quick summary, the process for dramatically speeding up and simplifying your CMDB implementation, of course, is the pre-planning up front. Which business services do you want to map? What are your critical business services that you want to do? And of course, as we've demonstrated here, using a FireScope SDDM will provide a visibility into all the assets that are on your network. So that way, if you do have Excel spreadsheets, you can always do a comparison with them. But it really is kind of a live view of what is happening in your network. And then finally, as we've also demonstrated in here, that one-click federation of the data into your CMDB can populate it very quickly. I did have one question. Actually, let's talk about the special offer first. So for everybody who's on the webinar today, we're going to be sending out an email afterwards that will contain a link to a special version of our software that is free for you to be able to download. Normally, we have a limit of 50 CIs, but for the people that are on the webinar, we're going to increase that amount to 100 CIs. And also, two, is that we're giving away 1 hour of consultation with one of our FireScope engineers. So that way you can actually work with them to make sure that you've got the instance of FireScope SDDM stood up in your environment and that you're actually able to start seeing value from it. With that being said, I know we're getting close on time, and we did have one question. Somebody sent me a question in here real quick. And Devin, I'm going to ask this question of you. The question is that does the FireScope SDDM product integrate with more than just Cherwell?
It does. Right now, we do integrations with a couple of big name CSM. So, for instance, Cherwell and ServiceNow, and then there are some other CMDBs that we integrate as well. Avante, Matrix 42, I think, or just a couple right offhand. But we're constantly innovating and adding new integrations all the time. So, but if someone whoever asked that question would like to get more information about that, I'm sure that we can provide kind of our roadmaps and things like that of when we are going to integrate new items.
Great, thank you, Devin. And for the other, we're actually out of time. So for the other questions that have come in, we will definitely be sending a follow-up email with the answer to those questions in them. Once again, I want to make sure that on behalf of FireScope that we thank everybody for their time today on the webinar, and look for those emails and those goodies coming to you. Thanks, everyone. Have a great day.